Assalamu alaikum everyone. I am Kashfia Tabassum. Today, I will present our project title Disaster Recovery Network Design for a Smart Manufacturing Factory using Point-to-Point Protocol and Frame Relay Redundant One Links. My teammates are Jannatul, Fardous, Anika, and Nusrath Jahan. This project focuses on ensuring continuous network operation and business continuity during network failures. Let's get started with the first slide. Objectives of the project. The main objective of this project is to design a disaster recovery network for a smart manufacturing factory. We use point-to-point protocol as the primary one link and frame relay as the backup one link to provide redundancy. The goal is to ensure high availability, reduce downtime, and enable automatic failover whenever the main connection fails. Now we are going to the next slide, which is introduction to our project. Modern manufacturing factories depend heavily on networks for production monitoring, employee communication, server access, and industrial automation. However, network failures caused by hardware issues, cyber attacks, or natural disasters that also can disrupt operations. To overcome these challenges, we designed a disaster recovery network with the primary factory site and a backup disaster recovery site. We're going to the next slide, which is theoretical background. Disaster recovery network ensures continuous communication and business operations during failures. The network uses redundancy and failover mechanisms to eliminate single points of failure. When the primary WAN link becomes unavailable, traffic is automatically redirected through an alternative path, maintaining uninterrupted connectivity. We're going to the next slide after this, which is point-to-point protocol and frame relay protocols. Here, the first thing we have, which is VLAN segmentation. There are 5 VLANs and 5 different departments. 10 goes for admin, 20 goes for HR, 30 goes for production, 40 VLAN goes for server, and 50 VLAN goes for IoT or PLC. Now we are explaining this slide. In this project, PPP is used as the primary one link because it provides reliable point-to-point communication and supports authentication. Frame relay acts as the backup one link and becomes active when the PPP connection fails. VLANs are also used to separate departments such as I have earlier mentioned admin, HR, production, server, and IoT or PLC for better network management and security. Here comes the next slide, which is network design diagram. This slide illustrates the overall network design. The primary factory site and backup disaster recovery site are connected through point-to-point protocol and frame relay links. During normal operation, all traffic flows through PPP, which is point-to-point protocol. If the PPP link fails, frame relay is automatically activated. And the backup site takes over, ensuring that factory operations continue without interruption. This was all my part, and the next will be elaborated or explained by my other teammate, Nusrath Jahan. Thank you.
Assalamu alaikum. My name is Nusrath Jahan. I will now explain the device configuration and implementation progress of our disaster recovery network. This slide, my topic is device configuration overview. This slide provides an overview of the device configurations used in the disaster recovery network. First of all, we configured router R1 at the primary factory site. The router was assigned IP addresses for the local network, the PPP primary one link, and the frame relay backup one link. Static routers were also configured to enable communication with the backup DR site. Similarly, router R2 was configured with its own LAN, point-to-point protocol, and frame relay interfaces. It maintains connectivity with the primary site and supports failover operations. The frame relay cloud was configured using DLCI mappings. DLCI 102 and DLCI 201 were assigned to establish the virtual circuit between the two routers, allowing the backup one connection of function correctly. The switches at both sites were configured to connect end devices and provide access to the department VLAN networks. After configuration, verification commands such as show IP interface brief, show IP route, and show frame relay map were used to confirm correct operation. Finally, a failover test was performed by shutting down the PPP interface on router R1. This allowed us to verify that traffic could automatically switch to the frame relay backup link, ensuring continuous communication between the two sites. Now we are going to the next slide, which is screenshots of different steps. After the device configuration overview, this slide is the evidence of the actual configuration steps. Figure 1, we can see the LAN interface configuration of the router R1 and R2. The Gigabyte Ethernet interfaces were assigned IP addresses 192.168.10.1 and 192.168.2.20.1, which act as the default gateways for the primary factory site and backup DR site respectively. Figure 2, the PPP main 1 link configuration is shown. The serial interfaces on both the routers were assigned IP addresses 10.10, 10.10.1 and 10.10.10.2 using a /30 subnet. This PPP link serves as the primary communication path between the two sites. These screenshots verify that the routers were configured correctly before testing connectivity and failover function. For this, now we are going to the second slide. For this slide, here, configuring the backup one path and the frame relay cloud. This slide shows the implementation of the backup one infrastructure using frame relay. The serial interfaces on router R1 and router R2 were configured for frame relay communication. The backup one link uses the network 10.0.0.0, where R1 was assigned 10.0.0.1 and R2 was assigned 10.0.0.2. This link remains available as an alternative communication path if the PPP link fails. The figure 4 frame relay cloud was configured. DLCI values were assigned to establish a virtual circuit between the two routers. Specifically, DLCI 101 was mapped to router R2 and DLCI 201 was mapped to router R1. The cloud connection was then configured to connect these DLCI and create the frame relay virtual circuit. And then we have third slide, which have figure 5. This slide presents the IP address assignment and VLAN configuration. In devices and servers were configured with appropriate IP addresses and default gateways. VLANs were created to separate admin, HR, production, server, and IoT departments. This segment improves network management, security, and overall performance. Then we have input-output screenshot. This slide represents the input and output screenshots of the implemented disaster recovery network. This slide shows the completed network implementation. Figure 1 represents the primary protocol point-to-point primary link and frame relay backup link. Figure 2 and 3 show the primary factory side and backup DR side with identical VLAN structures. These configurations provide redundancy, business continuity, and disaster recovery. After verifying the network topology and device configuration connectivity, tests were conducted to confirm successful communication between devices and validate the disaster recovery functionality. And then after that, the final connectivity test result of the disaster recovery is this screenshot. This screenshot shows the complete network topology consisting of primary factory side, backup disaster recovery side, and point-to-point protocol primary 1 link and frame relay backup 1 link. To verify implementation, ICMP connectivity tests were performed between multiple devices across the network, as shown in the simulation result at the bottom. This screenshot shows the final end-to-end connectivity test. And this verifies the successful implementation of the disaster recovery network. After that, during the implementation of disaster recovery network, several challenges were encouraged, which are problem analysis. Sorry for the network issues. I will again continue with problem analysis. During implementation, we faced challenges related to point-to-point protocol and frame relay configuration. DLCI mapping, failover latency, and network monitoring. These issues were resolved through proper configuration, connectivity testing, and troubleshooting. The final network operated successfully and made the project objects. I will now hand over the presentation to my teammate, Anika, who will discuss the sections results and discussion.
Thank you, Nusrat. Assalamu alaikum. I'm Jannatul Anika. I will present the result and discussion of our project. First, we conducted end-to-end connectivity testing using ICPM, means Internet Central Message Protocol (PIN). The result shows successful communication between our primary factory site and the backup DR site. During normal operations, network traffic flows smoothly through the point-to-point protocol main WAN link. If the primary fails, the frame relay backup link automatically activates to prevent any network downtime. We also verified our VLAN segmentation, which successfully isolates different departments link, admin, HR, and production to improve organization and security. In the next slide, here the advantage of the design. Moving on the advantages, our network design offers several key benefits. First, it provides high network availability and business continuity, means the factory operation never stops. Second, it uses point-to-point protocol and frame relay efficiently to deliver a cost-effective disaster recovery solution. Third, the infrastructure is highly scalable, which allows for future work expansion and growth. Finally, VLAN segmentation enhances network management and management control. The next slide is limitations and consideration. However, there are some limitations we need to consider. Although the proposed disaster recovery network improve reliability and business continuity, certain limitations should be considered when deploying and maintaining the solution. Setting up a secondary backup WAN infrastructure introduces additional hardware and link cost. The overall network configuration and maintenance can be complex. Also, our backup path relies on legacy frame relay technology, and real-world performance might slightly differ from our simulation results. The next slide is conclusion. In conclusion, we successfully designed and implemented a disaster recovery network using Cisco Packet Tracer. The combination of point-to-point protocol as the primary link and frame relay as the backup ensures continuous network uptime and seamless failover. The project perfectly achieved its goal of network redundancy, business continuity, and reducing production downtime. Next slide is future work. For future work improvements, we can upgrade our network infrastructure in 3 ways. First, we can migrate from legacy frame relay to modern WAN technologies like MPLS or SD, means software denied walled area network, to improve performance and scalability. Second, we can introduce automated monitoring and real-time alerting systems to minimize manual work during link issues. Lastly, we can expand the design to include cloud connectivity and advanced security layers for hybrid setups. Our references in the next slide. Here there are some references of our project, and thank you so much everyone for your time. If you have any questions, we would be happy to answer them. Thank you so much.